Hi, I'm going to walk through solving the integral of x to the third times the square root of 25 minus x squared dx. So the first thing to do with this is to use trig substitution. Since it's of the form a squared minus x squared, we can use the form a sine of x for the substitution. So I'll just rewrite this to make it even more easy. So you have the integrand of x to the third times 5 squared minus x squared dx. So then using the substitution x is equal to a sine of x, we get x is equal to 5 sine of x. And then dx would equal 5 cosine dx. From here, we can plug this back into the equation, and we will get some larger numbers. So we'll get the integrand of 5 cubed sine cubed of x times the square root of 25 minus 5 squared sine squared of x times 5 cosine dx. From here, the first thing to do is to simplify under the square root. So if we rewrite all of this, I'm going to bring this 5 over. So we're going to have 5 to the 4th times sine cubed of x times the square root of 25 times the quantity of 1 minus sine squared of x times cosine of x dx. From here, we can bring a 5 out from the square root because the square root of 25 is 5. And so we would be left with the integrand of 5 to the 5th times sine cubed of x times the square root of 1 minus sine squared of x times cosine of x dx. We can bring 5 to the 5th outside of the integrand, and 5 to the 5th is 3,125. So from here, this is equal to 3,125 times the integrand of sine cubed of x. And the square root of 1 minus sine squared of x is equal to cosine of x, just by that basic identity of sine squared plus cosine squared, sine squared x plus cosine squared x is equal to 1. If you move that around, you get that this square root is equal to cosine of x. So what we're left with here is the sine cubed of x times cosine squared x dx. This gets a little bit longer. Here we're going to use a method from, I think, 7.2. So this is going to equal to 3,125, the integrand of sine of x times sine squared of x times cosine squared of x dx. And we're going to use u substitution here. The reason I moved these around like that was actually because, again, of the same trig identity, we can set sine squared of x equal to 1 minus cosine squared of x. So 3,125 integrand of sine x times 1 minus cosine squared of x times cosine squared of x dx. And from here, we can use u substitution. So we're going to set u equal to cosine of x, and then du is equal to the negative sine of x dx. I'm going to bring that negative out front right away to get this equal to the negative 3,125 integrand sine of x takes care of this sine of x. Plugging in u for cosine of x, we get u squared times 1 minus u squared du. This then is going to equal, when we factor that through, negative 3,125 times the integrand of u squared minus u to the 4th du. And then we can break this apart into two separate integrals. This will become negative 3,125 times the quantity of the integrand of u squared du minus the integrand of u to the 4th du. The integrand of u squared is going to be u to the 3rd over 3. So we have negative 3,125 times the quantity of u to the 3rd over 3 minus the integrand of u to the 4th is going to equal u to the 5th over 5 plus c. Then from here we're going to have to undo the u substitution, and then from there, furthermore, we're going to have to undo the trig substitution. So from here, plugging in cosine, we're going to get this is equal to negative 3,125 times the quantity of cosine cubed x over 3 minus cosine to the 5th x over 3. And I apologize, when I did the substitution, I should have used theta probably to make this a little bit more clear. This is a little bit more confusing than it should be, and I apologize for that. But so from here, we have to undo the trig substitution to get our final answer. So to get our final answer here, we originally used sine of x equals 5 sine of x. So I'll write that over here. X is equal to 5 sine of x, which is the same as x over 5 is equal to sine of x. So if we draw our triangle, SOHCAHTOA, sine is equal to opposite over hypotenuse. So x 5, which means this right here is equal to the square root of 5 squared minus x squared, or 25 minus x squared, and then cosine of x here would be equal to, SOHCAHTOA, cosine is equal to adjacent over hypotenuse, so cosine is equal to the square root of 25 minus x squared over 5. And so then we can plug that back in to this equation, and doing so will get us something that's equal to negative 3,125 times the quantity of 1/3 times the square root of 25 minus x squared over 5 cubed minus 1/5, and I miswrote up here, that should be over 5, minus 1/5 times the quantity of the square root of 25 minus x squared over 5 to the 5th plus c. Simplifying this, you would bring in the exponent and multiply through. I think on the achieve homework, it let me, it accepted the answer finishing here, but if we want to bring that through, this could be equal to negative 3,125 times the quantity of 5 cubed is 125 times 3 is equal to 375. So I'm just going to leave that as the square root of 25 minus x squared to the third minus the square root of 25 minus x squared to the fifth over 5 to the fifth is equal to 3,125 times 5 is equal to 15,625. And then if we bring negative 3,125 through, we would get 3,125 divided by 375. That simplifies to negative 25 over 3, so you would get negative 25 over 3 times 25 minus x squared cubed plus, because the negatives cancel, square root of 25 minus x squared to the fifth all over, let's see what that simplifies to, all over 5 plus c. And so generally, either of these three probably will be acceptable final answers. But yeah, I hope that helped. Sorry, I should have used theta during this original substitution, which would have made this substantially less confusing. And so I'm really sorry about that. But I hope this helped.